Okay, so today we're talking about the derivative, and the derivative is all about the slope of the tangent, or the gradient of the tangent. And so that means we need to be able to look at lines to get a sense of what the slope is. And so just to review some important ones, this line here is going up and to the right, so it is positive. And because it's roughly perfectly in the center between horizontal and vertical, we say that that one there is the slope of 1. Similarly, this one is going down to the right, and because it's approximately in between the horizontal and vertical, this is -1. And so those are just two good reference points between positive going up and -1 going down. The horizontal line has a slope of 0, and that's an important one, really important for derivatives in calculus. And then this one here, well, there's a lot of estimating going on here. I know for sure that it's a positive value. Similarly, this is a negative value. And so, well, if I think about going up and over, well, I could say that's going to be about 2. If you said 3, that's okay too, but it's bigger than 1. And this one here, if I do the same kind of thing, I go down and over, maybe this one here, if this is 1, this is maybe 3, so maybe this is 1/3 negative, go rise of 1, a run of 3. But again, if I said -1/4 or -1/2, that would be okay, as long as I know it's negative and it's a smaller value than 1, it's less steep. And this one here is more steep than 1. And so that's kind of what we're looking at as much as estimating that as what we need to have. And so what we're going to do is we're going to let's look at Mr. Slope Finder. So here's my Mr. Slope Finder. He's working really hard here, going up and down the mountain. And so when we are here, we are going to look at this line here, this tangent line, and we're going to look at the slope. And I'm not so worried about the actual value of the slope as opposed to whether it's positive, negative, or 0. And currently, if I look at the 0, where its tangent means it just hits the curve just once, just bounces off the curve there, that is a positive value. So maybe it's a positive value, maybe it's 1, maybe it's 2. This isn't even labeled, so don't actually care. But when I take this slope, this line here, and I spin it around a little bit, horizontal, I can clearly see that at A, it is a horizontal line of 0. And so the derivative, the slope at A is 0. So I'm going to be putting a point there. Similarly, if I go to B, I'm also going to get 0. And now, I meant to say at the beginning of this, you should just watch this whole video first. Don't take any notes. Watch it first. Get a sense of what I'm doing. And then once you've seen me do it once, try and do it yourself, and then compare your answers. Okay, so pause it and try and finish it yourself. Okay, so now as I'm at B, if I'm going to keep on going, I also recognize, let me take this thing and lock it into place. When I move B, I can move it over to C, that's going to be 0. D is also what I've tried to make a horizontal tangent line here that goes horizontal for a moment. E is going to be 0, and then also down here I'm going to get F to be 0. And so anywhere that there's like the valley or the hill or even like a flat spot, I'm going to get the derivative, so the slope of the tangent is equal to 0. And so now that is what happens on the other side. When I pull my line, I know it was positive here at first. It was a positive slope here. But then when I get to the right-hand side of A, I come over here, down over here, it is a negative slope. Okay, and so it's going to be negative, negative. And so as it comes, it gets more negative here, more negative, right about here. And then as it gets lower, what starts to happen is it gets less negative, less negative, less negative, less negative, less negative, less negative, less negative until it's 0. So it's positive. It starts off positive, it gets 0, gets negative. At a point somewhere in the middle here, it gets less negative. It hits its most negative. It starts to get back to 0. And so you can see that this is 0 here. And then it does the same thing. It comes along and it becomes now, my slope is positive. It is positive, so it's going to be positive on this side. It's going to be positive, and eventually it's going to come around back to 0. And now this one's a little bit different, this range here. So when I pull it around, so I have my negative slope here, and it gets more and more negative until it hits more negative, and you can see it's 0. But then it goes back to being negative again. More and more negative as it goes down until it's down here, and then it starts to spin around to 0. So it's negative, 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 hits 0. So what's happening is negative, negative. Oh, what's happening is negative, 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 back to 0, but then it goes back to being negative, 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 all the way back to E. Now notice I don't care how far down at this point, how far down it goes. I just know they're negative values. And then I go back, the slopes here will be positive, and then on the other side of F will be negative again. So it's going to go positive, back to F. And somewhere in the middle here is where it switches, starts getting less negative again, or less positive. And so if we try to generalize it, what's happening between 0 and A? In this region here, I can see that my graph is increasing. So if the derivative is positive value is above the x-axis, the derivative is increasing. If it's decreasing, then the derivative is negative. It is below the x-axis, negative values. And again, it goes increasing, so it is all positive. And then it is decreasing, so it's negative. And it keeps decreasing, so it's still negative. And then it starts to increase again, so it's positive, and then it is decreasing to be negative. And so whenever the derivative, if it is equal to a positive, that means the original function is increasing. And similarly, if the original function is negative, the derivative is negative, then y will be decreasing. And if the derivative is equal to 0, if the derivative is equal to 0, that means the original function has a max or min, or what we call a stationary point. Or more specifically, this is a horizontal tangent line. These are all stationary points, a horizontal tangent line. And so now that you've seen Mr. Slope Finder's graph, try it yourself and see how yours compares to the video.